So appreciation of popular music probably started about 15 years ago, and I've been reliving the rockabilly era recently. It's been fun.
Oh dear.
I'm really happy to be able to introduce our next speakers, John Drury and NICOLE Calma. John is an assistant professor in the linguistics department, and before he joined us about 3 years ago, he was doing postdocs at Georgetown and at McGill University. His PhD is from the University of Maryland, where he wrote a dissertation in hardcore syntax in the areas where it gets really hard. And then he went off and did postdocs where he learned about neurolinguistics and psycholinguistics and experimental design and so on. So it's been a real pleasure having him here in the department, because he's been able to supply us with lots of enthusiasm, lots of expertise in experimental linguistics, but it's all filtered through a very strongly grounded theoretical linguistics filter, and so it's really great to say. I've been wondering if verbs really move. Oh yeah, experiment number 5. It looks like this. So we're generating these wonderful paradigms. You can see this in the activity of our students, because her main interest, I guess, is using ERP techniques to try to separate syntax from semantics, if it is possible to make that kind of separation. Some people have argued yes, some people argue no, some people don't argue. And NICOLE is a first-year student in the Department of Psychology here at Stony Brook. She was a former music major and then moved to linguistics, became a linguistics major, and then became a music minor. Here at Stony Brook, you have to file a form to change from major to minor, but for those of you in this room who know how to do that, you just flap the third and there you go. So many of us here in this room have had the pleasure of having her in our courses throughout the years that she was here as an undergrad. And I think, as far as I can tell, among those of us who are interested in the connections between linguistics and music, I think probably NICOLE is the very first one who said, I have an idea, I want to do a project. Can I do an honors thesis? Is there some way to get summer funding for this? And we said, sure. And so she wrote this honors thesis of about 3 years ago, I guess, 2 or 3 years ago.
Yeah.
And I was lucky enough to be the advisor on it, and it was just a real pleasure to work with her. And it's great to have her on campus, and I think this is a sort of a dynamite combination here between the two of them. And so the title of the paper is Revisiting Shared Resources for the Language of Music.
Can everyone hear me as I talk? All right. So I just, again, we're revisiting shared resources for language and music. This has been a really strong group effort, as most of my undergrad career went here as well. So for this project, we've also been collaborating with Laura Santa, which is also in the linguistics department here. Dan Feiner as well, Susan Brennan in psychology, and Michael Ullmann and Robin Miranda at Georgetown. Oh, okay. So most of our work, I guess just to start, we've been talking a lot about language and music. Today there's a lot of good reasons why we would want to make some comparisons with those two. We've talked about some of them already today as far as interaction between dialogue, interaction, performance, and so some other areas that this has been looked at is actually just the systems. So both language and music have really strong syntactic systems, well organized, rule-based, hierarchical kinds of structures They also are learned similarly as far as implicit learning. Most of what we pick up musically is pretty implicit. Even if we think we have no musical ability, we can tell when something's out of key. We can tell when something goes wrong somehow. We can have some kind of an emotional reaction to it. So as far as those, there's a lot of similarity in the systems. The theory that we'll be looking at most today is the shared syntactic integration resource hypothesis, which kind of makes the claim that you do have a lot of similarity, but there's also difference. So you have different representation networks. So you have, for music, you have your chords and your notes. And for language, you have your lexicon and your words, but that there may be some kind of overlapping or shared resources, so that what you're actually working with are different, but how you're working with them and the resources underlying what you're doing with these things might actually be shared. And one of the ways that we look at that is through the use of EEG data and kind of electrophysiology.
Right, so this is my bit. Okay, no problem. We'll do it. Right, so no problem. So here's how we do these kind of experiments. So I'm just going to take you quickly through how we get this kind of data, what it looks like, and some of the key kinds of effects that are interesting to us, both from the perspective of thinking about how language is organized and processed in real time, and music and what these things have in common. So the way we typically do this is we have our experimental victim. Right, they're trapped in our lab, they're in front of a computer screen or with headphones in and so on. We've got electrodes all over their scalp. Looks something like this, and a little fancy shower cap, right? We have them, it could be auditory, it could be visual, right? We have them, say, read sentences, make certain kinds of judgments, and the like. And while we're doing this, we're getting naturally occurring changes in brain activity we can measure from the scalp with electrodes. We amplify this signal, and we get, you've probably seen at some point or another an EEG trace, right? So we get this positive and negative a series of voltage changes over time. And so what we're interested in is what happens at particular time points when we present different kinds of stimuli to people, right? So what we do is, it's a little small on the bottom, but we time lock stimuli we're presenting to people, right, to these EEG signals, and splice out little bits of this, right? So maybe a second's worth or so, maybe longer if you're looking at longer latency kinds of things. That would differ across, say, two experimental conditions if we're interested in processing of one kind of word versus another, say, all right? So we grab a bunch of these, and through the magic of signal averaging, right, we combine these things together, so we end up with some characteristic average curve of these little timepieces for one condition to compare to some other. And what happens in practice is, when we look at these EEG signals, these signals are reflecting both brain activity we're interested in, right? So brain potential changes that are related to the events we're exposing subjects to, but also spontaneous irrelevant background activity that we don't care about at all, right? So what happens is, in general, by time locking these signals to the presentation of the events we're interested in, right, the things that aren't going to be systematically time locked to those things, the little peaks and troughs in the EEG will tend to cancel each other out. And what you're left with is a characteristic curve. So the bit of the brain potential that is related to the event in question. So this is an event-related brain potential, or ERP. And so then, as an experimentalist, you compare these kinds of curves across two different conditions. And if you're lucky, you get some interesting looking difference, and you get to publish a paper, and your chair is happy, and you get tenure. So what do we compare to what when we want to look at this kind of stuff, right? So here's one way. Am I over 3 minutes yet? Right. So here's one way we can do it. Right. Through the use of violation paradigms. And the basic idea, we can do this in lots of different domains. Basic idea is you find some dimension of some complex system you're interested in, and you break it. Right. Either in language, say, or music. Right. So, for instance, if we were interested in what's the timing of the systems that are involved, and the nature of the systems that are involved in accessing conceptual information from our lexicon and integrating it into a sentence context, we might compare two ERP curves, which are averages for lots of trials, and take the red and the blue condition here. And we get a characteristic kind of effect here. A couple of things to note. The little map here that I'm showing you in the middle, this is the head, like we're looking down, right? So there's the nose at the top, the right ear, the left ear, and all the little dots represent electrodes, right? So for this kind of manipulation, eating broccoli versus eating democracy. Forget about the Scalia bit. I was in it. Right, we get a characteristic kind of negative going response around 400 milliseconds. It has a broad distribution on the scalp. And initially we thought, the field thought, oh look, something connected with semantics or meaning and so on, right? It turns out not to be quite that simple. What's represented in these plots here, right, are again our two, the red and the blue curve represent these ERP curves for an average for, say, the red and the blue conditions here. The superimposed black curve is just the subtraction. And I'll be showing you some images of some other plots like that a little later, but so we know what it is. So we get one kind of negative going response, right, that shows a certain characteristic timing and profile and polarity for this kind of thing. But for other kinds of things, say we screw up verb inflection, right? We mess up word order, right? Max's of proof the theorem versus Max's proof of the theorem, right? This kind of thing. Elicits a characteristically different response, right? With a different scalp distribution, a negative followed by a positive going effect that folks have thought about as sort of a syntactic-y kind of profile from these kinds of things. And so this is what that looks like on the scalp. So these black lines here, these difference waves, we can take these for each of the electrodes on the scalp and make a nice little color map, right? So now it looks like we're doing real neuroimaging. Right? So we got a negative going thing, but around the half-second mark or so, maybe a little earlier, 300 to 500 milliseconds after you see something like, John will kicks, say, followed by this positive going distinction, right? So, yeah, this was really the golden age. So when I got into this stuff, this is what I learned, right? This I found, and I was a linguistics graduate student, and I thought, oh wow, that's so cool, right? All these questions that we ask as linguists about the nature of the way form and meaning are connected, right? All of the ambiguities and the theoretical tangles we have, right, between semanticists and syntacticians. So, no problem, right? We'll hook up the electrodes, right, and we'll show you, right? If it's an N400, it's semantics, LNP600, it's syntax. It really was a kind of Eden. But since then, we have been cast out by the harsh reality of empirical facts, right? So it turns out that this alignment between this one kind of ERP pattern in syntax and this other one in semantics is pretty hopeless, right? We have to think about these things as more broadly aligning to the way different kinds of memory systems and cognitive operations work that work not just this way in language, but in lots of domains, right? And so these things also turn out not to be language specific. One way of thinking about it, this is not all of the ways you can think about this thing, is to align these effects, these left anterior negativities with increases in working memory burden in some way, these N400 type effects with accessing and retrieving information from long-term memory, mostly kind of conceptual sort of information, but not only that, and these late positive going effects with some kind of series of operations that integrate and compose information, potentially across different streams of processing, right? So involve a bunch of different kinds of things. So here's some important points to remember that will come up again, right? Effects that have different scalp distributions, right? Positive, qualitatively or quantitatively different scalp distributions. From this, it's a fairly secure inference to say, okay, that means there's distinct underlying neural systems involved, right? This is not a secure inference, right? And so that is, finding the same scalp distribution for two effects, right, does not necessarily mean that. You can have different distribution, different underlying sources for these activities that can sum to give you superficially similar effects on the scalp, right? Here's another thing, right? You've got distinct generators for effects. These things will typically be additive on the scalp, right? Effect 1 that's positive going over here, effect 2 that's positive going over here. Look at them independently, you see what they look like. If you can manage to produce them together, they should sum, right? These effects should be additive. If it's the same neural generators, though, we expect some non-additive pattern, right? It could go one way or the other, depending on the nature of the system. Maybe something super additive, maybe something that's under additive. So here's the cool bit, right? We can now think about doing the kind of comparative cognitive science enterprise, right? Because we see similar kinds of effects for various kinds of manipulations of musical stimuli and linguistic stimuli, right? One thing that you'll see here, I just wanted to note it quickly, the musical analog of these left anterior negative going things sometimes is more right lateralized when you look at violations in music. We'll give you some examples in just a second. So you might also see in a plot, in case we forget to explain it, RAN for right anterior negativity instead of LAN for left anterior negativity. And It's your bit now.
So in Miranda and Ullmann's 2007 paper, we can actually see some of these effects at work. So they looked at music violations in familiar and unfamiliar melodies. So basically what they I'll actually show you their stimuli while I'm talking about this. So they would have a control familiar melody like Twinkle Twinkle, and then they would have violations in this. So they would have an in-key violation, which we won't be talking much about these, but I'll just give you a little background on what they did. So this would break memory, but it wouldn't actually break. So this would be a memory violation, but it wouldn't be something that if you didn't know the song, that you would say, oh, that's bad. So we have a little sample.
We don't have the
We don't have.
in-key ones,
Okay, we
right?
have.
Yeah.
So, but then out of key.
Relative to the music we've been listening to so far.
So out of key violation, you'll have a memory violation because it's not the note that you're expecting, but you'll also have this out of key where if you didn't know the song at all, it would still sound bad. That's an example.
Right, yeah. When we do cognitive neuroscience stuff, especially with EEG, which is a really sensitive technique, we gotta keep it simple. Versus.
Everyone cringed. Like watching people cringe across the room. So what they were manipulating, they had the memory violation, and then they also had a matched novel melody. So they had something kind of within the same range of Twinkle Twinkle, same length. If you look, the little star notes are the violation notes, so the control, they're good notes, but they're going to be the same pitch across familiar and unfamiliar. And same thing, in-key violation, which since you don't know this melody, would sound like an additional control, it's perfectly good, and an out-of-key violation. So you can perfectly good. And even though you've probably not heard that arrangement, you can still cringe when you hear the bad note. And so what they were looking at were, I'll show you in the next slide, but they see a lot of the effects that we've been talking about. And so they, and just also, if anyone had noticed, where the unfamiliar sounded eerily similar, those were presented first, so there wouldn't be any priming effect, just as a note. So they're looking for a couple of things here. So you could see with the rule violations, you would get, as John had mentioned, this RAN effect, where you have this right anterior effect, the out-of-key note, and also looking for the potential for some kind of an N400 effect, this kind of semantic-y kind of thing for the memory violation conditions. And also, we could expect something like a P600 for this. And so this is what their data look like. Kind of, there we see the RAN, what looks like. They have a little question mark on the N400, but it kind of looks that way in their data, potentially. And there we get nice P600. This was for familiar melodies and unfamiliar. So there it is.
Side by side.
Yeah. All right, and so then we're kind of left with the question of, do these just kind of, their study only involved music? There was no language, but they were kind of looking, we have this double dissociation in language, and they were kind of looking, do we have something similar in music? And so then the question is, are these actually the same, or do they just kind of look that way?
And there's some cool data suggesting, at least for some of these effects, right, that there's something to it, right? That there may be, at the very least, shared kinds of mechanisms, right? So this is a study by Patel and company in the late 90s, where they showed these late positive going effects, both for language violations, and so these are the waveforms for the language. The solid line here is a simple grammatical control. The dotted line here is a syntactically complex sentence, which elicits a larger such positivity relative to the control, and then an even bigger one when you encounter an ungrammaticality. And so what they did is, within subjects, but in separate blocks, they tested language and music and so on, did a language block like this, showing these P600 type effects for language, and then doing the same thing with music, right? So presenting an in-key chord and then either a nearby violation or a distant key violation. And you get this same kind of parametric effect, right? For the nearby one, the P600, but not quite as large as the one where you have this distant violation. And so if you subtract the big violation, right, from the control, right, we can look at these things together for both language and music. And well, I mean, they're quite similar, at least for a particular latency range. What the Patel study was able to show is that these effects are statistically indistinguishable, right? I mean, they look a little bit different, one lasts a little longer and so on, right? But for at least sub part of the processes underlying this effect, this is at least consistent with there being really shared or maybe even overlapping or identical underlying mechanisms involved. But remember what I told you. I asked you to remember some things. And one is that the same scalp distribution doesn't rule out that there's actually distinct neural generators, right? Because it can be very similar, but functionally, even if functionally similar, distinct underlying systems involved in these two domains. So, what do we do about this? Nicole will tell you. We should have put a barrier here and then see if we could still give this talk without seeing it. Figure out who's the sax and who's the piano player.
So one of the ways that we can do this is by putting language and music together, and that's exactly what Kolsch and company did in 2005. And so they had auditory chord sequences that manipulated musical syntax. So they would have a chord progression. The chord progressions had 5 chords. One chord progression was totally normal. The other had highly irregular chord in the context. In this case, it was a Neapolitan chord. They had visually presented sentences, so there was 1 chord per word, and these sentences manipulated linguistic syntax or semantics. So the syntactic conditions, the study was done using German, so there was a gender disagreement violation, and the semantic was with improbable continuations. And so, like I had mentioned, simultaneous processing, so the timing of the target word was at the same time as the target chord and target word. And this is what their stimuli look like. So these are an example of the chord sequences. And then over here we have for syntactically correct and high probability semantically, he drinks the cool beer. Syntactically correct, low probability is he sees the cool beer. And syntactically incorrect, high semantic probability is he drinks the cool beer, but there's a gender disagreement for the cool and beer. So what they expected is basically exactly what they got. So they had a violation of musical syntax, which gave them a RAM. Violation of linguistic syntax gave them the LAN. And the improbable continuation gave an N400. All the stuff that we've been talking about. Double violations, which are the more interesting ones, they found that the LAN was reduced for double language music syntax violations. So pointing kind of to this non-additivity that would basically be giving a lot of support for shared neural generators. So interim conclusions. Right now we've talked about the anterior negative going effects for language and music, showing non-additive pattern for double violations. So this is totally consistent with shared resources, as talked about in the SSIRH. And the P600 effects, so similar scalp distributions for language and music, but to our knowledge at this point, there have not been any within participants data looking at double violations for the P600. And also, then, is this additive or not? And so that's kind of what we did. So we were able to use the musical stimuli from LaMERG and Ullmann's study, but only using the control and the out-of-key violations. So we left out those in-key violations that were only manipulating memory. And so this is what our musical stimuli would look like. And melodies, we wrote up novel sentences, manipulating some linguistic stuff that I'll get to in a minute. And the melodies were presented simultaneously, so they were word by word, one note per syllable, presentation, with semantic violations and relative clauses. So the ball that John will kick versus the ball that John will bake. And from this, we would expect N400 and P600 effects.
For reasons we can address afterwards. So it less widely advertised is that you sometimes also get late positive responses for these semantic type violations. One of many reasons why it's not obvious due to the kind of one-to-one alignment I mentioned earlier.
So these are our conditions. So we have language good, music good, language good, music bad, language bad, music good, language bad, music bad. And so some of our goals were, go back on. Some of our goals were looking at language versus music N400 effects, kind of piggybacking off of the Miranda and Ullmann and seeing what happens when we put these things together. Insensitivity of linguistic N400 to musical syntax violations, as in the Kolsch, and there's also been previous work showing that this effect, that there's no interaction between these things, so we're looking to see that again. And also language versus music P600 effects. And this is the one that we'll really be focusing on today. We actually still have some data coming in about the N400 stuff, so we're not really prepared to comment on that right now.
Just to give you an idea. Wrong screen. Sorry. Okay, I'll try this later. I was going to show you what this looked like. But the basic idea is, as you're hearing the melodies, you're seeing words presented one at a time. So these cases. We had an end of sentence judgment task, which was focused just on the linguistic bit. So they were specific. They were told, subjects were told that they were going to hear also maybe some out of key, off key notes. That wasn't their job. Their job was to read the sentence, press the button, good or bad, if you think it's a normal, natural sounding sentence of English. Or not, right? We had 16 subjects so far. 2 have been dumped. One was out to lunch behaviorally. The other one produced the noisiest EEG data I've ever seen. They're all right-handed native English speakers, no history of impairment. We have some musical background information from these folks. And actually the reason we're not going to talk at all about the familiar and unfamiliar part of the manipulation is we haven't yet finished collecting the data that will tell us whether or not the people actually found the tunes familiar or not, right? So when we have that, we can talk about that. So concentrate on the P600. So we had accepted rates and reaction time for this end of sentence judgment data. These weren't particularly exciting, although basically you were a bit faster, right? If you got a bad word, you were faster at rejecting the ball that John will bake, right? If it was also came with a sour note, completely unsurprising, right? And you were a bit more accurate there. That's the green bar relative to these other ones. But strikingly, in terms of the acceptance rates, just to see that people actually were able to do the task, it turns out to be kind of tough. If I can get this playing later, I'll show you one, or if people are interested, I can show you later. It's actually not easy, right? And to focus on this one thing while you're also hearing these melodies in the background. In terms of ERPs, I will show you an electrode here. And here's our the 4 conditions, basically. So again, we're collapsing over the familiar and unfamiliar business. The black trace here is the control. The red one here is the music P600. So we were able to successfully elicit this kind of effect as we expected from the Miranda and Ullmann data, and we were using their stimuli. The language manipulation on its own, so just a bad semantic word, right, with a fine note, gives us this biphasic negative positive response, this N4 P600 response. And then the double case also gives us an N400 and what looks like a little bit bigger P600. And it turns out that these are crazy additive. Like, it doesn't get more additive than that, right? In fact, a couple of times I screwed up the colors on the plot and forgot which trace was which. They're on top of one another. So this turns out, right, this is the green, it's the language music difference wave, right, representing the subtraction of the green trace above from the control. The black trace that's superimposed there is the predicted pattern we'd expect, right? So basically the sum of the other two, right? Remarkable, right? These are indistinguishable statistically. So here's a view of this from the Scout. That's the P600 effect for the music case. For language, for the language plus music case, that's what we would predict on an additive model. And that's what we got. So here's the thing, right? Both the similarity of the P600 type effects that have been shown in the Vattel and company work from the late 90s, and the kind of interaction of the language music anterior negativities that NICOLE was talking about, have both been taken as pieces of the puzzle to argue in favor of this view, right? That, yeah, there's stuff that language and music has in common, right? They share, to some extent, they draw upon some shared underlying resources, right? In terms of how they're handled online and so on. But those resources during this kind of processing are connected with memory traces which are the stored representations of very different kinds of building blocks, right? So up until now, the P600 and the LAN type effects have been taken to be part of this story, right? To show, look, there is shared resources, right? And when we go look at the syntax stuff, we see that it's sort of shared syntactic. The findings regarding the anterior negativity still stand, right? What the present data show is that the superficial similarity that you can see in these positive going effects that have been demonstrated previously, right? Just because you look alike doesn't mean you're part of the same family, right? That these things for language and music may actually be really involve distinct underlying neural systems, right? Even if maybe involving, you know, parallel parts of similar kinds of circuits, even if they are functionally very similar in terms of the jobs they're doing, it's not the same bits of stuff doing the work in the way it is with the kinds of whatever processes we think may be working memory related that underlie these anterior negativities. So the lesson from this is, right, it would be nice on the one hand to show the kind of non-additive pattern for the P600, and you go, okay, good, I'm glad someone finally got around to doing that. That's consistent with this story, right? I think that these findings are still consistent with this story, right? Because again, the connection between the RAN and the LAN type effects, these things still stand, right? What we have to sort out now, and I think this is kind of important new data to help us understand what the nature of these late positive effects are, what the job they're doing in these two different domains, and what it's going to tell us about the general picture. But that's kind of as far as we are at the moment. And we'll just stop there.
This was probably on a slide, but I didn't pay enough attention.
Yeah.
In your study, what was the linguistic anomaly that you found syntactic?
Well, it'd probably be better to call it a conceptual semantic type clash, right? So it's the John 8 democracy type of violation. We did it in, I'll go back and find it. There's it. Yeah. We did it in relative clauses for a couple of reasons. One of them was based on some other data from my lab and from previous labs, is that if you introduce these kinds of violations in syntactically complex environments, especially places where you have to compute some distant dependency, right, in order to do the integration, you're likely to see these late positive responses in addition to the M400. And so the hope was maybe on our first crack we could get both of these effects in the data and look at them across language and music. The other part of this is we wanted to keep target words the same and manipulate other stuff, right? So the other part of this design, which we haven't run yet, introduces clashes between the auxiliary verb and the main verb, right? So the ball that John will kicked, right? The ball that John had kick, and so on, right? To introduce a more LAN P600 type pattern from the language stimuli as well.
So I'm just sort of wondering, under what theory of musical and linguistic structure, let's say we would expect musical anomaly like an out-of-key pitch to match up against a linguistic anomaly. Right? So I'm not totally sure that I would expect the kick-bake distinction to be the thing that would match up against, say, an F sharp and a C major context.
Yeah, agreed. So the reason to initially try, so all we cared about at the moment was, does the kind of effect that we can elicit that's connected with these conceptual anomalies, which we think at some point has to do with the way the context interacts with the mechanisms that are responsible for activating this information in memory. From the Ullmann and the Miranda and Ullmann paradigm, we had what looked like something like similar for music, right? Where you violate the expectations, but based on something you've stored in memory versus a novel token, right? And so the idea is, can we elicit both these same kind of effects in both domains and compare them? So we're not there yet.
So it would be exciting if ultimately we found something that was not additive, that we could make sense of as a shared property of linguistic and musical syntax versus, and then we could interpret results like yours as telling us, well, here's something that actually doesn't align.
Yep.
Yeah.
Exactly. Yeah.
Could the psychologist in the team elaborate on what I was last about?
I'm sorry.
You just mentioned.
Oh, I'm sorry. We had one of our subjects was just at chance for all conditions, right? They fell asleep. They had a behavioral task to do, and they clearly were not paying attention to it at all. So one of the subjects was rejected because it appears they weren't even attending to the task we gave them. Yeah, so we haven't included them in the data analysis. Sorry, yeah. Apologize for the strange. Yeah.
So, did one get the same N400 and P600 if the linguistic stimuli are auditory?
Yes.
I'm wondering about, yeah.
So these are, exactly, right, these, it's one nice feature about their properties are a bit different, right, and the waveforms look a bit different. Their timing is a bit different, right, but you get both the anterior negativities, the late positive P600 type effects, and N400s, these are all things you can elicit in auditory modality, right? So you can do all this with speech stimuli instead of reading.
Right, because I'm wondering about the resources here. There's listening and there's
Agreed.
reading, right? And one could look at a score of the music notes and hear the words. Would you expect it to be the same in that case with people who are really skilled readers of music scores or not?
It would be hard to do with this kind of methodology, right? So when we do reading stuff, when we're doing visual sentence presentation and so on with event-related potentials, we do this central presentation whether we're playing this game with music or not, because blinks and eye movements and so on cause huge voltage changes across electrodes. And those are, we either have to remove them in some way, right, or we need to reject trials that have those kind of movements. So normal left to right reading is kind of a non-starter for doing reading EEG research. People are starting to do it by co-registering eye tracking and EEG data to try to put this together and look at fixation-related brain potentials and so on. But so it would be hard to do the kind of thing where someone's following a score unless you could come up with the analog of the rapid serial visual presentation of notes, and I don't see why you couldn't. I had just thought of it now. Yeah. I don't know if anyone's, maybe other music people know, has anyone done that, right? The analog of note by note, I don't know, it could be self-paced reading, but you could do the same kind of thing, right? And it would just move.
Obviously doable, right?
Right.
Yeah.
I mean,
Cool.
A quick follow-up, another way you could get at this issue is to use sung sentences.
People have, there have been a couple of studies with some stimuli, and I think one of them at least was looking kind of more at the integration between the lyrics and the music when you're hearing them in the same stream. And I think I've read at least 2 papers with some stimuli, and they came up with, I think, slightly different stories, but from, I believe one of them at least, wasn't an EEG study though. It was behavioral, and they definitely found some more difficulty. I forget. I believe they were manipulating syntax in correct sentences, but that were more of varying difficulty.
Yeah, Ted Gibson's lab fits into the list. Yeah.
Mireille Besson has some beautiful stimuli that are excerpts from opera. And she finds exactly this wonderful additivity. It's just striking.
Yeah, and
What do you think about it?
Yeah, well, in that study, they have, they get a negativity for the one dimension that they're manipulating, and then this other positivity, and those effects are absent for the other one, right? And so it's true they find this really nice additive pattern, but it seems like they're, in that study at least, they're targeting these 2 rather different systems, right? So it was a little less surprising, But at the time, actually, that study was run, it was a live question, right, as to whether people had done the same thing by creating these kind of conceptual, world knowledge-y, semantic-y kind of violations and combining them with syntax, right, to see whether those things interact or not, or whether one blocks the other, so or this kind of thing. And yeah, for some of those things, you find additivity as well.
Another question, you said one of the responses is longer than the others, of music it's longer?
Get us in?
That one was more than the last.
The longer respond, the.
Oh. Yeah. Oh, yeah. The right for the Patel study, it was the P600 vector language was at least had a larger amplitude for a longer duration. Yeah. I don't know. Yeah. Oh.
So yeah, there's also this, I'm sure you know, this literature from stuff on Kolsch's group.
Yeah.
Besides the land stuff, where they argue about the M5 as like musical meaning and whether that interacts with the M4 or not. And it seems like it's sort of unclear, right?
It's totally related. And I mean, part of all this was, in fact, part of the reason that John Mayle and I started trying to organize this, the research group and so on, had to do with, well, what about all these ways? How do we explore the issues about meaning processing across these domains, across language and music? And a lot of the stuff that had been discussed that we could see in the music literature had to do with affect and emotion, and you know, not only that, but a large bit was about that. And I don't understand any of that. So I don't know how emotion works, and I don't know even how emotion researchers think about their domain, right? I mean, we have sort of kind of symbolic computational ideas about, you know, how the primitives of language are organized and so on, and those are and similarly for music, right? And we have ways of thinking about lining those things up. The idea would be to figure out ways of trying to have common language for those things, so you can make, you know, as David was sort of asking for, right, have a predictive account for how some of this stuff works. At the moment, our first pass is like, can we even show, like, is this the same or different? I mean, that's sort of the level at which we're asking questions at this point.
So you said for a second phase, you'll be doing things where you're taking some syntactic violations, like the ball, John Bake, and some things like that. So, David, would you expect to see perhaps non-negativity there because the tonality and the grammar will probably overlap that way?
With the inflection.
Right, so in other words, not expecting necessarily that semantic violations are going to be analogous to tonal violations, but that syntactic violations might be similar to tonal violations.
So, or maybe like one of the examples you gave, I think, orally had an of sticking into a sentence where it didn't belong. So something that's completely non-integratable. So the problem with, say, an agreement violation is we sort of understand it, right? And whatever that's about, we make an effort to pass over the violation. It's even not clear whether when we do successfully parse it, we're parsing it as a syntax violation or as a lexical use violation, right? But if you put something that, you know, makes no sense semantically, that's not demanded by, you know, that's not an approximation at a correct version of the sentence. So, you know, an of is stuck in randomly where it doesn't belong.
The ball that John will marry.
Or the ball that John will love.
I don't know, yeah. I mean, so we do have one of the other students, Brad Marchnik, is working in my lab, is working on a range of different types of paradigms, playing around with exactly these kinds of things. There's a huge literature on this, that much of it revolving around Angelo Frederici at the Max Planck Institute, right? About how these early effects connected with exactly these kinds of things, like where you expecting a noun and you get a verb, right? So not just an inflectional violation or something where, you know, you can recover in some way, figure out, or you get a function word in a place where there's no way you can integrate it into the representation that you built up to that point.
Or likewise, unfulfilled expectations, right? So like the incomplete cadence we heard in the morning,
For instance.
but with a subcategorization violation, where obligatorily transitive verb is not getting its object, for example.
Right. Yeah, so that's the thing. For those kinds of things, for things that are about argument structure, those actually elicit patterns that are more like this, right? So it turns out if you supply an extra noun phrase for, you know, like an unaccusative verb or something, right? So like Peter arrived John, right? Something like this. You get this biphasic N400, P600 type pattern, which seems different from actually the kind of response pattern you get for either for inflection or for word order violations.
The opposite, so Mary devoured.
Yeah. Yeah, it's harder because you don't know, you know, at what point, right? At what point is that? Have you decided, oh, I didn't get what I needed, right? So it's hard to time lock the signal to those cases. But I completely agree. These are the kinds of things you need to think about, right? In terms of what the violations are like in the musical system and why, and what system predicts that this should be of a kind, right? And similarly across the domains. That's the way we have to do things. Yeah.
This might seem to change the whole question from where you're coming from. But I suspect that a big difference is when you're listening to music, you're listening to it with an aesthetic attitude. And when you're listening to a sentence, I'm not sure that you're adopting an aesthetic attitude. So that's got to...
I was listening to your talk.
That's right. And so something that might be a closer example would be either actual excerpts from poetry or poetic-like things composed for ad hoc examples, composed for comparison.
Yeah.
I mean, that's a different part of the story, right? But I think that complication is...
No, it's interesting. There's a million, there's always a million uncontrolled things, right? And, you do the best you can. But this kind of thing hadn't really ever occurred to me, like sort of what the, what your attitude is toward the perceptual event, right? And
then, I don't know why pitch is very appealing, but you go, or something, it's a trombone that plays the note, right? Or suddenly it's there's so many ways you could violate it musically, and I don't know that they would have the same effect. The ball that John will kick, the ball that John will kick. I don't know.
Something we haven't played around with here at all, but which became immediately obvious as we started building the stimuli is the gazillion different ways you could play with linguistic versus musical phrasing, right? To create matches and mismatches across the domain, right? And we have many cases where things are a bit weird, right? Where you've ended a phrase on the ball, right? Just because it was really super hard to do. The way we built these sentences was, let's figure out how many notes we got, let's line up that many words, and we got to get the target word in the right place, and then build in as much before so that it would be least sensible, right? This is our very first pass at it. But you can, you name it. Pick your favorite dimension of that you'd want to try to register how people process that distinction, and you could play that game. Is it Dan?
Yeah, this is kind of in response to David's questions and points. I mean, in some respect, the kick and bake sort of versus the F and F sharp in the C major context, I think could be thought of as in a sense part of the the numeration. These are the things that you can use. You can build your lines out of, or your sentences or your musical phrases. Whereas in the inflectional violations as well as other things, it's once you've assembled these things into some kind of a structure, it's the sort of local dependencies or non-local things up in higher parts of the structure that are relating to each other. And I guess if those are the ways to think syntactically, then it's a question of what the analog would be in the musical domain of agreement or encoding encoding between one thing and the other thing. And I guess the tension resolution that we've seen talked about in a couple talks might be something like that. So if you're going up here, then you have to come back down here or something. But I don't know how you'd correlate that with agreement or filler gap dependencies or something.
Yeah, I don't know how to play this game.
Be a bear
honestly, I mean, I'm looking forward to David's talk later. It's not easy to figure out what the analogs of this versus that would be, right? So in a sense, our starting point for this is this sort of bottom-up empirical one in a sense, so that which things across the domains, given other things people have already explored, seem to show similar kinds of patterns. Does it look like those are the same mechanisms or not? Do they interact or not? So, and along the way, building up a set of tools in terms of experimental paradigms that you can use to probe this stuff. So you get reliable kinds of repeatable patterns that you can show, look, well, these things are kind of the same, or these things interact, these things don't. As a toolkit, as an experimental toolkit then to address, if somebody comes and tells you, look, I've got a theory that says X in music and Y in language are the same thing, and here's my other independent evidence, and here's my sort of theoretical motivations. Super, I can test it, right? But I don't have those things other than very vague ideas about both of these systems involving, holding information in memory, using that information to predict what's coming next, right? Having to, for the familiar case or for when you're retrieving words from your lexicon or something, having to retrieve information in some way from long-term memory and hold it in memory long enough to integrate it with the context and so on, and feed this forward to some more durable memory trace, for however it is we represent discourse and this kind of stuff, right? Other than these kind of very vague ideas, I don't have a theory in hand that covers things across the domain in a super nice way. Just these broad cuts, right? And some broad effects that look the same.